This is episode 11 of Software Design from the Beginning. In this episode, we're going to try and bring all the terms that we've been discussing together in some kind of ontological approach, some kind of mapping, some kind of process flow and mind map, if you will, of all the sorts of terms we've been mentioning and a few others, kind of put them together, have a look at it, what's the big picture, right? So let's have a look at what I've prepared here. To start with, basically the domain language. We've gone through this. We've had a look at domain language, domain objects and processes, and we understand that the box and the line, the first and second law of software design, this is basically what I'm drawing out here. Boxes and lines, we can see relationships between these things. Now the domain language is something on the business side. We're really talking about if you're in logistics or if you're in the hotel industry, then you have a domain language and a process and a workflow that you're following. So really the domain language, objects and process go through a kind of a requirement cycle where a need is found and we want to optimize existing process or we want to build something new, but we're going to have requirements. We're going to have some kind of optimizations. Now this kind of language is business side, like I've said, and that means that people are not thinking necessarily in software terms. This is not architecture. This is not object-oriented code or classes or anything like that. This is really just business. And so somebody like a business analyst or a business architect might be looking at the business and how the business functions, what requirements and needs there are in the business. And of course they are responding to forces. Now, if I go up here, I've put a few of these kinds of forces. These are not all, obviously, but we got customer need and business needs. We've got law, ethics, and compliance. And these filter through as requirements that the business, has to put in place, right? So either it's a requirement because it's a compliance mechanism, or, a customer has requested something and it's a pretty good client and they need to respond quickly. So whatever the forces are, we can list them here as forces pushing down on the domain language and the process and any optimizations and new features and so on that are built. And we call these kinds of requirements functional requirements, usually because it is functional. We're saying that the customer needs to accomplish something, the business needs to accomplish something in the software perhaps. They all filter down to requirements. Are they all functional? No. Right? So sometimes a compliance mechanism ends up being somewhat functional, but really the desire is not going to be some kind of export format or something like that. But there might be a compliance in terms of, let's say, permissions in a database or security, encryption in passwords and so on. And so they might filter down into something that you can call functional, but really they are forces and they are playing around with the domain language and processes of that business. And business really needs to respond to these requirements. These requirements, they have to be responded to because the customer really wants it and you don't want to lose their business. The business is perhaps not efficient in a particular process and you know that if you did something in the software, you could be more efficient. So down here, I've got it as optimizations. Now, optimizations and requirements often feed into each other. You have a requirement, and that requirement might have some kind of solution or, some sort of meta problem, and you might need to optimize that as well. So it's not purely that you have requirements that you need to solve. Sometimes requirements have a solution which causes problems, which needs a requirement, and so on. So it can be a lot of back and forth here. Whatever the business analyst or the business architect desires here for moving the business forward and complying or settling a customer need, it has to be translated into software. And if I move down, this is really where we're looking at systems theory and paradigms, subsystems, relationships of all these actors in the system, right? How do they piece together? How do they form some kind of cohesion? How do we think about software? The paradigms. We've been over little things like this. So we might use object-oriented, we might understand and divide up the system into conceptual layers, and these might be influenced from a software standpoint, but conceptual layers and systems theory, they might very well come from the domain language and the processes that are required here. They are very much influenced, but there is a form of translation required because we don't have a one-to-one mirror, right? We can't say that, a logistics vehicle has an object already on the side of the fence and we have an architecture that can deal with bookings and so on. We don't, so we have to build it. So if we look at the forces, if I think about what design means, design is taking forces, ultimately ending up as requirements, with a strong understanding of domain language and processes. Those requirements are tweaked again and again for optimization, and then they are translated. And they are translated into computer speak, right? They are translated into how we design systems. And how we design the systems, how we interpret that, is based on our understanding of the ontological processes involved and systems that we work with. What kinds of theories do we have in systems theory? How do we put these systems together? How dynamic or static they are, and so on. Paradigms. Are they object-oriented? Are we building a flow or a pipeline? Are we using design patterns, and so on? If we move down conceptual layers, what we're really saying is that we're going to design an architecture. The architecture should suit and fit within our view of the world here. And of course, it must suit the requirements. So when we build architectures, we are now taking the functional requirements and building them into something that we can call an architecture. And architecture itself has problems, right? And we might call this non-functional requirements. Others call it the T's or the E's or the qualities. We've got availability, efficiency, scalability, affordability. We've got dozens more. And these kinds of requirements are just what we need to accomplish in order to make our architectures robust and stable and so on. So let's just go back through it. We have forces that build requirements. We have to understand the domain language to filter those requirements and then translate them into our view of the world. And our view of the world turns those paradigms and understandings into an architecture. And that architecture requires these non-functional requirements. Here's a list. This is from Wikipedia. Here are a list. It's a little list, right? Here's a list of qualities of the architecture. So dependability, debuggability, credibility, correctness. Ooh, doesn't have an ility at the end, right? There you go. So architectures fit at this kind of level. If I zoom out, this is kind of what we've got to face with in design. Now, to address something about design and architecture, I want to point out, I think it's a good time to do that because this diagram is here. What is the difference between design and architecture? Well, it depends on how you look at what that word really means and how you look at it. I'm going to give you one sort of take on it. One could say that designing a system has all of these considerations and more. So you could say, I am designing a system that looks at these kinds of things. So these kinds of things would obviously be influential in the design. Are these things design? Probably not. We can't say that, systems theory or requirements is design itself. It's probably just influencing the design. We design something because we have a certain limitation or boundary or constraint. We have requirements, we have optimizations, and we've chosen an architecture and so on. So the design is influenced by things like this. Does that mean that a domain process is a design? Probably not. Is a paradigm a design? Probably not. If we're looking from the context of what we are designing to match a requirement for the business domain, then probably what we're looking at is that designing is the act of building a design with influential factors such as this. So notice I haven't said architecture as such as its own thing. In my view on this, design is not architecture, because architecture is only one of the conceptual layers of what you are designing. It is only one part. To call design architecture would be kind of alienating all these other things that you need to pay attention to. You're saying that design, software design, is purely architecture or some form of design patterns or architectural patterns and so on. That's really not looking at the big picture of what design is. So my first point would be that design and architecture is not the same, because ontologically speaking, architecture is just part of conceptual layers, and it's the same as a systems theory, for example, or some kind of paradigm. And we don't say that a paradigm like object-oriented is a design. What we say is that object-oriented can be used to design something in the paradigm of object orientation, right? So object-oriented is a method of design. It's a style of design. If I look at what architecture might be as point number 2, if I look at architecture and I look at availability, efficiency, and so on, is it true that availability is design? Well, if availability is a quality of architecture and we design the architecture, we might be led to believe that availability is a form of design, but it's not. To me, availability is just the nature. It is just the quality of the architecture which you designed. Okay? So architecture is an output of designing, and availability is a quality of what was output. Right? So if you consider availability and efficiency and scalability and so on, and you have that architecture taking care of these things, then yes, you have designed for these qualities. Does that mean that architecture and design is the same thing? It means they are not. Architecture and design are used colloquially. They are used interchangeably by people who don't really understand the difference or care about the difference. Does it matter that there is a difference? Well, pedantically, yes, but everyday wording and terminology is probably not. You're going to say, well, I'm going to go and design the design. Fine, you want to use that word. That's not a problem. I like to see variations because I like to see a mapping and some kind of relationship between things. And when I think of architecture and design as an interchangeable term, then I cannot see the relationship between other things. For example, I won't be able to see a conceptual layer or a difference between a conceptual layer and an architectural layer if I think that all of them, all these terms are just design. Okay, so I hope that gives you sort of a little bit of a zoomed out look at what design is. And I'll just on the side here just mention we've got forces, we've got functional requirements, business architecture leading into perhaps enterprise architecture. We've got software architecture on this side of the fence, and typically the fence would exist somewhere in there, right? This is where we're going to translate our business architecture to some kind of software architecture. Where this line is entirely dependent on organizations. Okay, and where you choose to place this. But generally speaking, it'll be somewhere in there. Right, a thin layer somewhere in the translation area. Now, if you're a software developer, then, whether you're a lead developer or, a lead in some way where you're doing some design, where are you sitting? Well, you're probably sitting down here, right? Perhaps with architecture somewhere in here. Now, a software architect is really concerned with this level here somewhere. And if you don't have an architect, then who is worrying about this architecture? Sometimes I find this is a bit of a void because there is a developer sitting here who doesn't have a firm grasp of the layer above here, but is designing software at this point. And so therefore you will have some kind of gap between what is translated and what's coming through. So a software architect, in the traditional sort of definition of that role, I know it is slightly ambiguous, perhaps a hands-on software architect might be concerned with things from this level all the way down. Right? And sometimes it's quite difficult to be hands-on when you're considering all these other things. It is made a bit easier when you have an enterprise architect who is worrying about some of the higher level things, and then you have an architect maybe that comes in at that point over there. How you do this and how these roles fit into design is entirely up to what you follow in terms of methodologies and so on. Anyway, I hope that gave you an overview, and we will be talking more about this in the next episode, especially down into architectures, and we still got to cover an acronym called BRACE. Thanks for watching.